Hello there. Give me 1 second. All right. I'm Phil Cruz. I was part of Team 5 in integrating PLC and HMI touchscreen input. That was our goal. As I said, the goal of this project was to make a system that used the PLC and HMI together. The first objective was create and outline a system that basically could use this. And what we used was Lab 2 in this class that Dr. Stagon had provided us. Basically, the goal of that lab was to make a heater that, when put into an aluminum block, would start heating it up. And the temperature sensor connected to the PLC will measure that temperature and see how hot the aluminum block was. This project was broken up into 5 parts. It was broken up with the wiring, basically making the entire system, the diagrams, all that. The ladder logic, we had to make the programs for the PLC. We then had to make the screens on the HMI, configure that. We had to connect the PLC and the HMI, and then we had to run the entire system. As you can see, the ladder logic is right here. It's 9 steps in total. The first 2 steps was the temperature sensor connecting it to the PLC. And basically, when it would connect to the PLC, it would connect to the HMI and display that temperature that was displayed from the temperature sensor to the HMI. We then have our third step right here, which would basically set the heater on or set it off when we had our HMI working. Then steps 4 through 9 basically say that when the certain temperature is hit, that the system will start changing. So basically, if it is below, the temperature is below 50 degrees, the PLC will have an LED that will go blue, it will turn on blue. And then if it goes above 50 degrees, there will be a red LED that will turn on and the blue one will turn off. If the entire system reaches 55 degrees, then the entire system shuts off. The HMI was a difficult part of this project as it was the least known part. To set it up, we had 4 steps. We had to set up the HMI screens. We had 3 of them. That was the title screen. The second displayed the heater buttons, the heater button and fan. The third displayed the analog temperature, and that was it. The second step was to create a switch that would turn the fan here on and off. Like I said, we had that. And then the third step was to set a meter that would basically show how hot the aluminum block was getting. And then we had to set up an alarm that when the heater becomes too hot, it would signal us, signal that it was getting too hot. And the temperature that we set for that was 53 degrees Celsius. After that, the next step was to connect the PLC and HMI, which was probably the hardest part of this project. There were some steps, though, that once we followed, the system started working. The first step is to make sure that your PLC and HMI are connected. This was actually, it seems easy, but it was difficult as you're going back and forth trying to program the PLC and the HMI. A lot of times we were trying to figure out what was wrong with our program when we simply didn't plug it in. The second part was the PLC protocol in the Seymour software. The Seymour software is for the HMI. And basically, there's a protocol that when connecting to the PLC has to be set. The one that we were originally using was the Click Serial software. However, the one you have to be using since Do More runs on the PLC is the Automation Direct Do More serial. The next step was to make sure that the baud rate of the HMI matched the PLC. The baud rate of a system is basically how fast the system is going. And so you have to make sure that the systems are running at the same speed. The next step was to make sure that the tag data types of the objects of the HMI match the memory types of the elements that they are matched to. So if we go back right here, you can see you have Y2, Y1, and Y0. Basically, you'll have the same thing for the HMI. Make sure that your Y2 of the HMI is matching the Y2 of your PLC. All right, and next is time for the demonstration. So I'm going to stop sharing my screen, and then I'm going to pull that video up. Just 1 second. All right, this is the second video. I'll pull up the first one. So here's our system. We have the PLC. We then have the blue button on because the system is below 50 degrees. It hasn't turned on yet. So it's going to be below 50 degrees Celsius. We have our aluminum block right there. We have our temperature sensor and our heater connected with the fan on top. And then here's our HMI. So I'm going to get the HMI. I'm going to enter. This is our screen. As I said, we have 3 screens. The first one being the title screen. You have back and next to go to the other screens. I'm going to turn the fan on. I see. There we go. So as you can see, it was slowly starting to blow. The paper was moving. The fan is on. So we're going to take that. We're going to go back to the HMI, turn that off, turn it on. And this is where the temperature would be displayed. Excuse me. It goes up, it goes at a very slow rate, so you won't see it moving here, but give it some time and you will see the temperature slowly starts to go up. So now I'm going to pull up the second video. Alrighty, here it is. Now you can see that the red LED is on. It's 50 degrees Celsius. It's hotter now, much hotter. So that's why it's showing that. Now the system starts to go off because now it's at 53 degrees. Give it a second. There you go. And the alarm is going off, signaling that it's too hot. And that is Team 5's project. Thank you very much for listening. This was a very fun class. I was glad to be able to take it with Dr. Stagon. I hope anyone who takes this class has just as much fun as I did. Thank you again for listening.